So, the first question, how would you pronounce my last name? That's the most tricky part of the whole presentation.
Dzianisau.
That's right, actually that's translation from Belarusian language. In Belarusian it sounds like Dzianisau, which is really close to Denisov, which is the Russian version. Okay, so let's say more than 26 years in IT and more than 23 years in EPAM systems. Mostly doing the database development, administration, performance tuning, mostly on Oracle database. A lot of experience with the ETL and BI reporting, mostly tuning the Oracle BI servers. I also have two publications. First one is a Metalink note related to the Oracle BI applications 796 version performance tuning. And also I have an article issued in Select Journal of the International Oracle Group in Canada specifically. Well, that's happened in the past. Recently I haven't written any article, so let's say this is my first appearance in the public for many years. Okay, so what are we going to talk about today? The first one is the AWR review. That's mainly Oracle database thing. Just a question, how many people here have an experience with Oracle database? Great. So probably you've heard about the AWR. If not, then you will be familiar with it soon. Okay, next we will talk about the typical problems during the troubleshooting of any issues. Not only performance, but just anything that you want to see or you don't want to see. Next section would be a short introduction about the AWR analysis for the developers. A lot of the people could say that AWR is the pure DBA thing, but this is not really true. You can utilize it in a real life, I mean in the development process, in the support process, and in the QA process, really easily. And the final point is how to enhance your analysis of the AWR information. Okay, so what is the AWR actually? This is an answer to the questions. If you want to know how healthy your database is, if you want to get rid of the really complicated troubleshooting sessions, especially when you don't know what's happened and you still need to analyze what's happened, especially if you have really complicated system, complicated applications, sort of it, and everything is working in the same database, and you just need to figure out what actually happens. That's the AWR. And actually, if you want to really quickly understand if anything happened with the database, just in a seconds, or database is not an actually bottleneck, and the application is the reason that everything is slow, that's also the AWR. So let's stick to the AWR review. So the first is, AWR is a background process, which is doing something in the database. Mostly it's doing snapshots every hour by default, by settings, but you can change it and do it every 15 minutes or every minute, whatever you like. You just change it, you can change it. And also a set of tables, mostly internal tables with the views built in on the top of those tables. AWR need to store some data, so those tables are here. AWR is also a set of the reports. Text reports, HTML reports, so you can generate it by using this information from AWR views. And as I already said, AWR takes snapshots every hour by default. You can change it if you really need it. And also what it has, it can capture the hardest SQLs that happened during this last hour, or let's say several hours. Since AWR just running and running and running, it can keep a history for a month. Or you can just download it and keep for I don't know how many times, just for your own purposes or for analysis or whatever you like. But anyway, you can keep this history and create baselines and compare it with the current state and so on and so on and so on. So basically, AWR is a historical data which can show you what's happened in a database in the past. So what exactly we have in the AWR? We have wait events, which can show you exactly where database spending time on waiting for something. Either it's waiting for physical reads or physical writes, or logs, or for instance redo, just anything. Everything is stored here, and you can easily identify what exactly happens in a past, in exact time, and see actually what is the reason of such a behavior of the database. So some information can be grabbed from the dynamic performance views. In other words, $V views. Basically, those views are showing you real-time information, which means that in every second you are querying this view, it will show you right the value for the certain statistics in this time. So next time you will be querying this view, it will show you the new value. And basically, the good point is that just as an AWR does, you can sample this data as well and write it into your own table, for instance, and use for the data analysis. And actually, if you remember such a things like UTL stat or statspack utilities, available since Oracle 7 and for UTL stat and I guess and statspack from the Oracle 9, I guess, or 10, I don't remember exactly. So basically it's the same thing, just capture statistic at one point in time, do some workload, capture it again, and use delta to provide the exact analysis, at least to provide the information about what's happened here. AWR actually does the same thing, but in more enhanced way. So what also AWR has? Object usage statistics. So you can see what's happened with the object's access in the past. Which tables, which indexes, and so on and so on and so on, and you can see it here. Also, you can see the timing statistics about what's happened with the processes, how many times processes are spending on doing their work. And of course, resource-intensive SQL statements. That's an AWR. So, where to find the data? If you want to dig into, you can query DBA hist and anything view. You can go to the documentation, specifically Oracle Database Reference, which has information about all the views, packages, objects available in the system. And if you will filter it out by DBA hist prefix, you will see a bunch of them. Actually, in Oracle 11, there were just 111 DBA hist views. Right now, in Oracle 23, we have 162. So basically, each version brings us a bit more and more and more information. Actually, AWR is available starting from Oracle 10. So you can just utilize it from pretty old versions. So the most frequent objects are, of course, snapshot, which contains information about the all snapshots available in the AWR. So basically, you will see it by default for each hour. Snapshot ID and some information like begin and end dates and any other information. But if you want to know how many snapshots you have, just go there. So next one is a SQL text, which contains exact SQL code executed in the database that's happened during this snapshot capture. Also SQL stat, which has all the statistics about the elapsed time, about the physical reads, logical reads, and so on for specific SQL statement. Basically, you can marry the SQL text and SQL stat and get the SQL code and the statistics for the SQL execution. And also, it has SQL plan. You know that plans change sometime, depending on really different situations. I have a small story just about it. At one company, people just figured out that in case if it was raining in the Monday, database was behaving really slow for some of the reports. In case of no raining, database is fast. They tried to analyze what happened, and actually the reason is that in case of raining, a woman that should come early in the morning had to pick up her kids to the school. and she was late at the job. But since she was late, another person was running the same report but with different parameters, and Oracle generated a different SQL plan. And her reports became slow. In case of no raining, she just came first and execute the same report with the different parameters, and plan was absolutely different. And what is really important, that each weekend DBA took a cold backup of the database with shutting down instance. So basically, at the morning, it was a pure new instance with the, let's say, empty memory about the execution plans, statistics, and so on and so on. So as you can see, here you can grab plans, historical plans, and know what's happened actually. So what if you don't have access to AWR? In terms of any reason, like remote environment, lack of restrictions, just, I don't know, any reason, if you can't access it, you can ask DBA to download it using those scripts. So using the scripts to extract it, and then use a script to upload it to your environment and start using it. So basically you can have your own small server with only 2 CPUs, and you can grab it from the production system, just the statistics, and start analyzing it. Okay, here are the scripts for generation of the report. The only difference between those 2 scripts is the second one can generate your report for single instance, while first one will generate your report for a whole cluster. So, how it looks like. That's a header, which has information about the actual database, release, edition, so on and so on, and also environment, amount of the CPU cores, memory available, and also statistics about the start of the snapshot and the end of the snapshot. And also database time and elapsed time for the snapshot. Basically, elapsed time is just the difference between end of the snapshot and start of the snapshot. It's just calculated here. Database time is actually how much time database spent on doing work, by all the SQLs, all the code executed between those 2 dates. We'll talk about it a little bit later, but this is really valuable statistics. So here we have a load profile, which has also information about the database time and the database CPU spent per second, per transaction within this time frame for the snapshot. You also have logical reads, physical writes, just a lot of things, SQL work area. So basically the major information is assembled here. Of course, it is aggregated. But anyway, just taking a look into this part, you can easily say that I don't like exactly this row, and let's start to dig from this place. You don't need to figure out the exact number, like 300. What 300? It can be 6, no matter how many. But if you think that it looks suspicious, you just need to start dig from this point. Of course, getting more experience, you can just utilize it much more easily. So here we have another aggregated information, like database CPU with the total wait time and also percentage of the database time. So basically you can see here that database CPU was utilized for 93% of the whole database time. You also can see the exact event name, like DB file sequential read, which means mostly index access path, or direct path read, which write, which means the process of writing directly into the database table segments, like for instance during the ETL load. Or you can see the DB file scatter read, which also shows you that there is some physical I/O happened on the database. For the weight classes, you can see breakdown by weight class. So basically each weight event belongs to the specific weight class. Either it's application or user I/O or concurrency or network, and you can just see the total statistics for a specific weight class. And you also can see the I/O profile for the database requests, requests and megabytes, redo, optimized statements in total. So basically, that's just another point of the aggregated information you can use for just at the very beginning step of analyzing what's happened with the database. And basically, those links are links to the different segments of the AWR report. If you will generate it, you will see that this is a huge document with with a lot of the information for different parts. Like, for instance, not only the SQL statistics, but also for instance activity, also for different cache statistics, also for table statistics and indexes statistics, just a lot of things. You can also see the weight event statistics for different types, like foreground weight statistics for events which are serving your queries, or background statistics or services statistics. Basically, today we will not review the whole AWR report. This would take a lot of time. Basically, it would take about 8 hours, maybe more, especially if we will just start to think, to discuss just some, not internal, but specific things related to certain AWR report. So basically, that's a short description of some of the views which can be frequently used. Like, for instance, system event will show you information about the weight events. Again, if you will stick to the snapshot ID, just a single snapshot ID, each statistic will tell you nothing. It will tell you just a number, like 300, 600, whatever. But if you will take a look into the pair of the snapshots and calculate delta between the values, that's a valuable information, because you can see that during the past last hour, we see that we have workload for physical reads like 600 of something. But for the next hour, we see that this number increases, and we can see that workload for a database increased. So for sys-time model, that's another view that will show you some system information. Event histogram, that's a really valuable thing that will show you distribution of the weight events by time weighted. Each weight occurrence will take some time. It can be a really short period, but it can be also a huge period, depending on the system workload. If you have a lot of the processes which are trying to query very heavy tables and join them, and performing a lot of the full scans and performing the full table joins using the, for instance, hash joins and utilizing the PGA memory for each process, you will see here a lot of the information about the temp table space utilization, also a lot of the information about the physical direct path physical reads. And basically, in this particular case, you can see that 10 events are spending, let's say, less than 1 millisecond. But 600 events are spending time between, let's say, 1 second and 2 seconds. Which means that each such event was waiting, let's say, from 1 to 2 seconds. Having 600 events, we can just figure out that we spent about 1,200 seconds just on this part. So basically, that's really important. For SQL stat and SQL text, I already told you. Last but not least, it's an active session history, which is actually information about each SQL statement execution. Oracle has dynamic performance view called $v active session history, which contains sample in memory of every second of database queries executing, and keeps this information for 30 minutes. Here we have a dump of this view, but the only reason is that it has just 1/10 information from the $v. So basically, in $v we have each second sample. Here we have each 10th second from the $v. So you have 10% of the information, but anyway, since this happened in the past, you still can capture the weight events, you still can capture the CPU work from here, you still can capture execution plan from here, you can just see how everything went in the past. So that's really important and really good thing. So actually, what are the typical problems during the troubleshooting sessions? Customer security policies. You can imagine that nobody would like you to access their production data. because of many reasons, like sensitivity of the data, especially GDPR, just really sensitive data, like for instance financial or military. It can be also a requirement for physical presence in the office, just because of the special cases of the security, like in bank systems, for instance, when DBA should be sitting just right next to the server room. Also closed networks, or DMZ. So basically every such a case will not allow you to, let's say, easily provide the troubleshooting session in terms of any type of the troubleshooting. Performance, bug fixing, bug analysis, just security issues, whatever. So another point is remote environment, which also can have a lot of the restrictions like security keys, probably VPNs, probably even, I don't know, desktop sharing something. Or, for instance, if you do have, you can have just an SQL access. But in terms of the SQL access, you also can have a lot of the permissions, like accessing the DBA views, for instance, and still you need to ask DBA to provide you this permission. So another interesting case is offline support, when you have just an email or phone calls. I had an experience of such an offline support when I was working for Oracle BI applications PSR team. We had cases when customer escalations in terms of performance were assigned to us, and we had a special support engineer who was just doing a copy-paste from customer support request to Oracle BugDB, where we had an access, so we could read from it, ask a question. So this support engineer just copy-pasted back to the support request, and all the exchange was done in this way. So that was really interesting. And another point is the complexity of the troubleshooting session. You need to figure out what, when, why, just a lot of the questions. And in case of really complex system, sometimes it's not really obvious where to start, especially if you are DBA or database engineer who is working with the database part, and still you need to figure out what's happened and probably say and prove that this is not a database fault. Okay, so time for the real story. Some time ago, we've been asked to help one of the project team to help with the database performance, because they had a lack of time of tuning the application in a database, and they had just 3 months before the delivery. So it was a, let's say, multi-country team. There were a lot of people from Belarus, from Ukraine, landed to the office, and actually we started to work. Our team from Belarus came second. Ukrainian team was the first. They were starting just 1 day before us. And what they started to do, they started to use the Trace 46. Do you familiar with the Trace 46? What is it? That's an Oracle session trace. So basically, you can just enable this 146 event and generate everything what session does during the lifetime to the specific trace file. Then grab file from the server file system, run the special utility called tkprof. It will just reformat it for you, and will provide you information about each statement, each execution plan, each statistics for the statement. So how many reads, waits, just a lot of the information. But the only problem is this is related to a specific session only. In case if you have connection pool, which just grabs connections for each statement, just like execute this for the session A, execute second statement on a session B, and so on and so on, this thing becomes a real nightmare. Because in this particular case, you need to enable this trace for every session. And also have an access to the server file system, which is sometimes not possible because of a lot of the restrictions, especially security restrictions. So basically they started to use tracing, and it took about 2 hours just to generate this trace file. So basically create a test scenario, run it, and grab the trace file back. It took just up to for 2 hours for one scenario. A lot of time spent for nothing. So AWR, that's the question actually. As I already said, by default AWR creates snapshots by 1 per hour, but it is allowed to generate your own snapshots. So basically what you can do, you can generate snapshot, do your work, and generate another snapshot. So that's another part. So basically how it looks like. Last statement is just how to generate the AWR report. You can generate either text or an HTML version and save it. The only point is, do your work here. You can execute a lot of the SQL statements by your own, or you can ask, for instance, QA engineer to click application steps, or execute ETL process and just do something. Or, for instance, ask performance team to run a workload test. Just anything, but do your work here and just grab snapshots, that's it. So, how to read the AWR reports? Basically, just like a book, top-down approach, from the beginning to the end. So, report starts with the settings overview, right? Next, top 10 weights. And finally, what you need to do, you just need weights to analyze what's actually happened. If you see high amount of weights for a specific weight, like physical reads or logical reads, just start digging from here. Basically, what's important is to know your workload type. If it's a transactional system or data warehouse. Again, for data warehouse, we're not talking about the reports only. We also need to still keep in mind that we have ETL process, which has a lot of the rights to your data warehouse. And you need also to figure out and split the workload. For a night process, that would be probably a writing process. For day, probably reporting, so reads. For online transaction processing, pretty similar situation. Short reads, a lot of writes, especially for retail, for instance, or just for any type of the transactional processing. And we also have a possible issue with the redo-undo. And also sequential read, which means the index access, especially if we are accessing the same index and many times, even for a short transaction. But we'll still see the sequential read wait event, and we can just figure out what's happened with the index and just read a guide, specifically Oracle reference, of what to do with this specific event. Or you have another option, access the My Oracle support and just dig into this as well. And actually, My Oracle support will provide you much more interesting information. Sometimes even some internal things. Sometimes, not always. So, critical things. If you see DB file type, that's a physical I/O. Buffers, logical I/O. So basically, any access to the buffer, even if it's an index access, Oracle first reads it and reads it into the memory, and then gives it an access to this part of the memory and shares it across all the sessions. So that's a buffer reads, and this is a logical. In case of log types, that's a redo-undo. PX, that's parallel query. GC, that's for global cache, specifically for application clusters, but in case if you are not DBA developer, you just need to skip it. In case if you are DBA, then you need to play with it. Okay, so the most interesting part. Average active sessions. That's a metric which is not covered directly by AWR. At first time, it was introduced, I believe, in 2010 by Kyle Haley. And actually, that's a single metric that can show you just in 1 second from your AWR report that either everything is okay with the database or not. or you can, a database is okay, but you still need to look into something. So basically that's a single metric that shows you the database performance. I can easily say that something happened. And there are two methods to calculate. Either sampling it by the accessing $v systems systat view, or take the AWR. So what you need to take into account for the AAS also? The amount of the CPU, that's the only thing. So at one hand, AAS, in another, CPU, and you need just to compare it. Well, we have subcomponents, CPU, weights, and time series. Okay, so the sources, systat or AWR. So how to get AAS? That's really easy. You have elapsed time for a snapshot, you have a database time. Database time means how many time database spent on your requests. Elapsed time, the duration actually for this work. And basically, you just need to divide DB time by elapsed time and get this metric. That's it. This is the magic number. That's a golden metric, I guess. The next step, what to do? CPU. Sorry for typos, sometimes it happens. I spent a night on doing this slide. But so where to get it? Still AWR, you have information about the CPU cores available. For this one specifically, that's Oracle Database 3 instance, which is available for download. This is an image for VirtualBox. You can download from the oracle.com and use it for free for development and, let's say, investigation purposes. So, we have CPU, we have AAS. What to do next? So, in case of AAS is much lower than 1. This means that no issues with the database. Well, of course, there can be some statements that need to be revised. But definitely, globally, if you see this, database is okay. If it is close to 0, database is idle, no workload. So this is an application, in case if you just hear that database is slow. No, it is not. In case of AAS is less than total CPU number, well, we're okay because database is not loaded actually. I mean for 100%. But we still need to know if we have just one session doing its work just constantly and constantly. For instance, we have duration of the snapshot for 1 hour, and we can have statement that's, let's say, calculate some averages for, I don't know, for a whole history of the tradings for 100 years, just calculating tough metrics and so on and so on. And it takes a lot of the time just to provide the full scans, joining tables, calculate it, blah, 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 blah. And so we have just one session doing the whole work for a whole hour. In this particular case, we can easily say that AAS can be just 1, occupying single CPU to do its work. And we can easily extract this statement from the AWR report. Well, in case of AAS is bigger than CPU, then probably we have problems. But we definitely need to see the workload, we need to see the weights, we need to see the database time statistics, CPU utilization, and so on and so on. So basically, here we can start to work. Well, in case if average active session is much higher than CPU, it's time to work hard. But basically, you have this metric. And if you can just easily calculate it and see it is near to 0, you can say, guys, that's not my fault. So basically, that's just a brief description of what we're talking about. Okay, so that's when to start working. In case if you have an access to the server, you can just figure out that response time of the server just started to jump. Even if 100% of CPU utilization is fine, but still you need to see if users in the queue. In case if they are, probably you have pretty old hardware or misconfigured, but anyway you just need to figure out. In case of issues with memory, a lot of paging, a lot of swapping, again wait time is jumping, and response time for the work also jumping. In terms of Oracle, we exactly know what to do. Waits are higher than CPU utilization, start with waits. CPU is much higher than 100%, start with the top SQL queries. Everything else, that's an application. So, about the enhancement of the analytics. So, this is how it started. Just imagine the job that generates your AWR report each hour and just stores it somewhere in the share. Each morning, you have 24 report for each instance of your cluster. You need to check out everything for 24 hours of history and just try to compare everything. And just to remember that 6 hours ago I saw something suspicious and I need to compare it with the current value. So that's a really pain. Sometimes I can't just figure to keep in my mind 2 snapshots, but what about all this? So basically, the next thing is how to mine the AWR. As I already said, we have snapshots. We have 1 hour between 2 snapshots, and we can use delta between specific information for this snapshot. So here is the brief example of the physical reads for different snapshots and a delta, and the additional calculation performed for seeing the physical reads in megabytes per second. Of course, each number for a start value or end value will tell you nothing, but the delta will show you that there were such amount of physical reads occurred between these exact snapshots, so you exactly know that starting from, let's say, 1 p.m. to 2 p.m. we have this amount of physical reads. Well, using calculation of knowing the block size of the Oracle database, specifically 8K for instance, knowing the time, knowing the delta, you can calculate actually the exact reads information for megabytes per second. And you can see that at this time we have increased metric. At this time everything is okay. So that's actually how I enhance this statement. Do you know what is the model SQL? It also have another name. It's called Excel-like SQL. That's a feature of Oracle database starting from, I believe, Oracle 10. You can go to the documentation and read the Oracle Data Warehouse guide with the chapter model SQL for model or something like this. It will tell you the exact syntax and what to do with it. Actually, this syntax is perfect thing to calculate deltas, because just staying on this row, you can argue to row before and row after, similar to lead and lag functions. But here you can just refer to exact numbers. For instance, as you can see, the formula just built at the last and last but one lines, like val of CV of snap ID -1. So basically this means that staying on current line, we want to grab this information for current line, but -1. For instance, for snapshot ID, -1. Knowing that on this snapshot and snapshot before, they are differ just by 1 digit, just by 1 value, you can easily calculate it and then just calculate delta for it. So basically here, what we have calculated. Adding additional formula by utilizing the block size, you can easily calculate reads per megabyte. Okay, so this is the last slide, actually. This is a, let's say, a report split it just by 2 times because it was too wide to split to fit on the screen. That's this report I've created a while ago, and basically it shows the information about the header from the AWR. As you can see, we have the AAS column here already calculated. We also have CPU time, database time, background CPU. Also have the physical reads, logical reads, a lot of things. And the good point is it has some details available. It is not shown here, but in case if you are really curious, we can just have a talk after session. I will show you exactly what I'm talking about. But basically, right now I don't need this bunch of the AWR reports generated somewhere. A bunch of the HTML reports. Well, of course I do. I still do need them. But all the details I can grab from here, at least the review. And exactly say that during the last several hours, I have increase or decrease of the workload. And can easily dig into the details for a specific snapshot. Or a set of snapshots. Basically that's it. Okay, questions?
Is that query available somewhere?
Write me an email. I can share it with you. It's not a top secret. And by the way, you can enhance it. I can share with you the whole report. It's written for the SQL developer. If you know this tool, Oracle SQL Developer, it has ability to create user-defined reports, which can be either 1 section or 2 sections with the master detail things, stuff like that. I can show you just right after the session. Okay. Any other question?
Okay. Any new AWR features in Oracle 23, like in the report itself?
Basically, not really much. You just let's say, last 2 years I haven't spent much time with an Oracle. I'm mostly working with the Snowflake right now. So basically that's my, let's say, kind of pet. I'm playing with it from time to time on my own sandbox. But for the Oracle 23, I'm not up to date right now. But it still works. So let's say, last time I was working, it was Oracle 12 with the Exadata environment, which was real fun. Especially we had 3 environments like Dev, QA, and production, all 3 on Exadata. That was a magic thing.
How much it cost?
I don't know, customer pays. But the good point, the customer is really rich. They have about 40% of Corona beer in North America in the market. But recently they switched to marijuana, actually. Once it legalized in USA, as far as I know, they just bought a lot of the marijuana fields and they switched to this business. Or maybe extend. Okay, gentlemen. So far so good. Thank you very much for your attention.